Hi dear students, welcome back to online classes. I am Virupaksh BP. In last class we were discussing about periodic trends in physical properties. The first physical property is atomic radius. In last class we have discussed about what is atomic radius and what are the types of atomic radius and what are the factors affecting on atomic radius and the trends of atomic radius in the periodic table. In today's class we are going to discuss about the second physical properties, that is ionic radius. What is ionic radius? The distance between nucleus and outermost shell of ion is called ionic radius. The distance between nucleus and outermost shell of ion is called ionic radius. And there are two types of ionic radius. One is the cationic radius and second one is anionic radius. The first one is cationic radius. Cationic radius. First, what are cations? What are cations? The positively charged ions are called cations. Then how cations will form? When neutral atom it loses one or more electrons, then it forms cations. When neutral atom loses one or more electrons, then it forms cations. Okay, what are cations? The positively charged ions are called cations. How the cations will form? When neutral atom loses one or more electrons, then it forms cations. For example, lithium. What is the atomic number of lithium? 3. And write electronic configuration for lithium. 1s2, 2s1. And it is in atomic state. It is atom. When it loses one electron, the atom will convert it into ion, that is cation. Lithium will convert it into lithium plus by losing one electron. Here the atomic number is 3, but the electronic configuration is 1s2. Why? Because it has lost one electron. So the electronic configuration becomes 1s2. Here it is cation. Positively charged ion is called cation. And the cationic radius is always smaller than atomic radius. Cationic radius is always smaller than atomic radius. What is the reason for this one? Why the cation radius is always smaller than atomic radius? The radius of cation is always smaller than radius of atom. Why? The reason is after losing electron, number of electrons decreases, but number of protons are same. See here there are 3 electrons, 1s2, 2s1. After losing electron, how many electrons are there? 2 electrons are there. Number of electrons are decreased, but number of protons are remain same. Here 3, here 3, because number of protons is equal to atomic number. So here atomic number is 3. After losing also the atomic number is 3. The number of protons are same, but number of electrons are less. Because of more number of protons, their effective nuclear charge increases for remaining electrons. When effective nuclear charge increases for remaining electron, the remaining electrons will strongly attracted to the nucleus. In such cases, what happens? The size decreases. After losing electrons, After losing electrons, number of electrons decreases. Number of electrons decreases. But number of protons remains same. As a result, due to this, effective nuclear charge increases on remaining electrons. Therefore cation radius is smaller than atomic radius. This is the region. Just for example, I will show here. This is nucleus and this is outermost shell. See here, in 1s shell, how many electrons are there? 2 electrons. How many protons are there? 3 protons and 3 electrons. 2 electrons are present in 1s shell and 1 electron is present in 2s shell. After losing one electron, what happens? Due to more number of protons, here the force of attraction between remaining electrons and the nucleus increases. That's why what happens? The size decreases. After removal of electron, what happens? The force of attraction between remaining electrons and the nucleus increases. So the remaining electron strongly attracted towards the nucleus. That's why the size decreases. This is the region. Next, this is cations, and next one anionic radius. First, what are anions? Negatively charged ions are called anions. How anions will form? When neutral atom gains one or more electrons, then it forms anions. When neutral atom gains one or more electrons, then it forms anions. What are anions? Negatively charged ions are called anions. How anions will form? When neutral atom gains one or more electrons, then it forms anions. For example, fluorine. What is the atomic number of fluorine? 9. Now write electronic configuration: 1s2, 2s2, 2p5. Okay, 1s2, 2s2, 2p5. When it gains one electron, the atom will convert it into anion. Here it is neutral atom. Neutral atom means what? Number of protons and number of electrons are same. See here, number of protons are 9, number of electrons are 9. This is neutral atom. But by gaining one electron, what happens? See, by gaining one electron, fluorine becomes anion, F minus. Here the electronic configuration becomes 1s2, 2s2, 2p6. But number of proton is same. Here it is atom, neutral atom. But after gaining electron, it becomes anion. See here electronic configuration is 1s2, 2s2, 2p5. Here electronic configuration is 1s2, 2s2, 2p6. Why 2p6? Because it gained one electron. It is denoted by negative charge. Now, the anion radius, the anionic radius is always greater than atomic radius. Why anion radius is greater than atomic radius? Because by gaining one electron, number of electrons increases, but number of protons are same. Because of more number of electrons, there is a more interelectronic repulsion. Due to more interelectronic repulsion, the force of attraction between nucleus and electron, outermost electron, decreases. That's why the anionic radius is always greater than atomic radius. See here. In first energy shell, there are 2 electrons. In second energy shell, there are 2 electrons. In last shell, there are 5 electrons. 1, 2, 3, 4, 5 electrons. This is neutral atom. There are 9 protons and 9 electrons. But by gaining 1 electron, what happens? Due to same charges, by gaining 1 electron, due to same charges, what happens? After adding 1 electron, there will be more interelectronic repulsion between electrons. Because of more interelectronic repulsion, what happens? The force of attraction between nucleus and outermost shell decreases. When the force of attraction decreases, then size increases. If there is a more force of attraction, then size decreases. If there is a less force of attraction, then size increases. Here why force of attraction is decreases? Because of more interelectronic repulsion. I will write here anionic radius is always greater than corresponding atomic radius. Why? What is the reason for this one? The reason is, after gaining one electron, number of electrons increases. But number of electrons are increases, but number of protons are same. Number of protons are same. As a result, what happens? Due to more number of electrons and less number of protons, what happens? There will be more repulsion between electrons. Due to more repulsion, what happens? Size increases. As a result, interelectronic repulsion increases and effective nuclear charge decreases. That's why anionic radius is always greater than atomic radius. This is the reason. Now I will write order of ionic radius. This order of ionic radius. Between atomic radius and cationic radius and anionic radius, which has more radius? Anionic radius is more. So anionic radius is greater than atomic radius. Atomic radius is greater than cationic radius. See here, why anionic radius is greater than atomic radius? Because by gaining electron, interelectronic repulsion increases. That's why anionic radius is greater than atomic radius. In this case, atomic radius is greater than cationic radius. Why? Because losing electron, number of protons increases. As number of protons increases, the effective nuclear charge between nucleus and electron increases. That's why the size decreases. This is the order, it is very important. Here the difference in radius is due to change in number of electrons. Here there are more number of electrons, that's why its radius is greater than atomic radius. Here there are less number of electrons, that's why at cationic radius is less than atomic radius. Here the difference in radius is due to difference in number of electrons. The next concept is factors affecting ionic radius. The first one, as positive charge increases, ionic radius decreases. Ionic radius decreases. Second one, has negative charge increases, ionic radius increases. Ionic radius increases, right? See here, as number of electrons increases, negative charge increases, right? As number of electrons increases, negative charge increases. As negative charge increases, ionic radius increases. Why? Because of more interelectronic repulsion. And as positive charge increases when more and more electrons loses, then positive charge increases. As positive charge increases, ionic radius decreases. Why? Because here effective nuclear charge increases due to more number of protons. Okay, these are the factors affecting ionic radius. Next, trends of ionic radius in the periodic table. Ionic radius, the trends of ionic radius are similar as trends of atomic radius. The trends of ionic radius is similar to trends of atomic radius in periodic table. Okay, this is ionic radius. Next one, isoelectronic species. What are isoelectronic species? Iso means same, electronic means electrons, same number of electrons. Isoelectronic species have same number of electrons but different number of protons. Isoelectronic species have same number of electrons, but different number of protons. Due to different number of protons, there is a difference in ionic radius in isoelectronic species. So here I will give example: O2 minus, F minus, Na plus and Mg plus 2. These four species are isoelectronic species. Why these four species are isoelectronic species? Because in these four species the number of electrons are same. Now let us check whether same number of electrons or not. First, atomic number. What is the atomic number of oxygen? 8, fluorine 9, sodium 11, magnesium 12. Next, you write number of electrons. How many electrons are present on O2 minus? Generally in neutral oxygen the number of electrons are 8, but there is a -2 charge on oxygen. -2, that indicates extra electrons. How many extra electrons are present on oxygen? 2 electrons. 2 plus 8, 10 electrons. 10 electrons. Next, come to second one. Here, how many electrons are present in neutral fluorine? 9. But there is a negative charge, negative minus 1 charge. That means 1 extra electron is present on fluorine. 9 plus 1, 10. Next, here, what is the atomic number of sodium? 11. Number of electrons are 11. But there is a plus 1 charge on sodium. Plus 1, it indicates less number of electrons. 11 minus 1. How many electrons are present on Na plus 10 electrons? Why? Because there is a plus 1 charge on sodium. Next, come to magnesium. Here, what is the atomic number? 12. How many electrons are present in neutral magnesium? 12. But in magnesium plus 2, there are 2 electrons are less. Plus 2, it indicates less number of electrons. How many electrons are less? 2 electrons. So 12 minus 2, 10 electrons. See here, in these 4 species, the number of electrons are same. That's why these species O2 minus F minus 1, Na plus Mg plus 2 species are called isoelectronic species. And these isoelectronic species, they are different in radius. They are different in radius. Why? Because due to different in number of protons, there is a difference in radius between isoelectronic species. Isoelectronic species have different radius, have different ionic radius. Here, why there is a different ionic radius between isoelectronic species? Because different number of protons, but number of electrons are same, but number of protons are different. That's why there is a difference in radius of O2 minus, F minus, Na plus and Mg plus. Isoelectronic species have different ionic radius due to different in protons, different in number of protons. Next, in isoelectronic species, the atomic radius is inversely proportional to number of protons. Here, atomic radius or ionic radius is depend upon number of protons. It not depends on number of electrons, because in isoelectronic species number of electrons are same. That's why the ionic radius is decided on the basis of number of protons. So here, atomic or ionic radius, ionic radius is inversely proportional to number of protons. As number of protons increases, ionic radius decreases. Now let us see some examples. Arrange the following species in decreasing order of their radius. The first one, in first question there are 3 species. One is Fe, Fe plus 2 and Fe plus 3. We have to arrange them in decreasing order of their radius. Now tell me, between these 3 species, which has more radius? Fe or Fe plus 2 or Fe plus 3? Which has more radius? Just you follow this order. Anionic radius is greater than atomic radius, right? Atomic radius is greater than cationic radius. Now tell me, between these 3 elements, which has more radius? Iron. Atomic radius is more radius than cationic radius. So iron. The radius of Fe is greater than Fe plus 2 and Fe plus 3. Next, between these 2 species, which has more radius? Fe plus 2 or Fe plus 3? As positive charge increases, radius decreases, right? That's why the Fe plus 2 has more radius. compared to Fe plus 3. Fe, the radius of Fe plus 2 is greater than Fe plus 3. This is the decreasing order of their radius. Next, come to B. Between these three species, which has more radius? H plus, H or H minus? According to this order, anionic radius is always greater than atomic radius and cationic radius. So, between these three elements, the radius of H minus is greater than H plus and H minus. The radius of H minus is greater than H plus and H. Now, between H plus and H, which has more radius? Atomic radius is greater than cationic radius. So, the radius of hydrogen is greater than H plus. This is the decreasing order. Next, come to third one, F and F minus. Between these two species, which has more radius? Anionic radius is greater than atomic radius. So, F minus is greater than F. Next, come to fourth one, O2 minus and O minus. Which species has more radius? O2 minus or O minus? As a negative charge increases, radius increases. So, O2 minus has more radius than O minus. The radius of O2 minus is greater than O minus. Next, here there are four species. One is O2 minus, F minus, Na plus and Mg plus 2. Now, according to this order, cationic radius is smaller than anionic radius. That's why first you consider two anionic radius. Between these anionic radii, between these anions, which has more radius? O2 minus or F minus? Which has more radius? O2 minus. O2 minus is greater than F minus. Next, you consider cations. Between these two cations, which has more radius? As positive charge increases, radius decreases. That's why the radius of Na plus is greater than Mg plus 2. The radius of Na plus is greater than radius of Mg plus 2. In this way, we have to arrange the given species in increasing or decreasing order of their atomic radius or ionic radius. The next physical property is ionization energy or ionization enthalpy. What is ionization energy? The minimum amount of energy required to remove an electron from outermost shell of an isolated gaseous atom is called ionization energy. The minimum amount of energy, required to remove an electron from outermost shell of an isolated gaseous atom, is called ionization energy. This is important. If atoms are in gaseous state, then only we can remove the electrons. If atoms are present in solid state, we cannot remove the electrons. What is ionization energy? The amount of energy required to remove an electron from outermost shell of an isolated gaseous atom. Example, sodium. The atom should be in gaseous state. What is the atomic number? 11. Write electronic configuration 1s2, 2s2, 2p6, 3s1. Now tell me, what is ionization energy? The minimum amount of energy required to remove an electron from outermost shell of gaseous atom. This is the outermost shell, right? The amount of energy required to remove an electron from outermost shell of gaseous atom is called ionization energy. If you provide a suitable ionization energy, then the gaseous atom, it loses one electron and it becomes gaseous ion. The gaseous atom, it loses one electron and it becomes a gaseous ion. One electron, it loses one electron and it becomes a gaseous ion. Now what is the electronic configuration? The 1s2, 2s2, 2p6, 3s1 becomes 1s2, 2s2, 3p6. Okay, this is example for ionization energy. And the ionization energy process is endothermic process, because here energy is required to remove electron. That's why it is endothermic process. It is endothermic process. Endothermic process. So delta H is positive. Always the delta H is positive for ionization energy, because here to remove electron we need energy. That's why it is endothermic process. And units. Ionization energy we express in electron volt per atom or kilojoules per mole or kilocalorie per mole. Kilocalorie per mole. Now let us discuss about successive ionization energies. To explain successive ionization energy, just I will take magnesium as example. Magnesium. The magnesium atom should be in gaseous state. Now what is the atomic number of magnesium? 12. Write electronic configuration: 1s2, 2s2, 2p6 and 3s2. This is the electronic configuration. Now if you add suitable ionization energy, this gaseous magnesium atom, it loses one electron and it becomes a unipositive gaseous ion. If you add suitable ionization energy, what happens? This ionization energy, it removes electron from outermost shell of gaseous atom. After addition of suitable ionization energy, the gaseous magnesium atom converted into unipositive gaseous ion. Unipositive gaseous ion. Again, if you supply a suitable energy for unipositive gaseous ion, then the unipositive gaseous ion will converted into dipositive ion. If you add a suitable ionization energy for unipositive gaseous ion, then unipositive gaseous ion will converted into dipositive gaseous ion. This is a dipositive gaseous ion. Next, again if you supply a suitable energy for dipositive gaseous ion, again the dipositive gaseous ion, it loses one electron and it converted into tripositive gaseous ion, Mg plus 2. This is a dipositive gaseous ion. If you add suitable ionization energy for dipositive gaseous ion, it loses one electron. And it becomes a tripositive gaseous ion. Tripositive gaseous ion. Just now I will write electronic configuration. Just here, what is electronic configuration? 1s2, 2s2, 2p6 and 3s1. Here 1s2, 2s2, 2p6 and 3s1. After losing one electron, the electronic configuration becomes 1s2, 2s2 and 2p6. Next here 1s2, 2s2, 2p6. After losing one electron, it becomes 1s2, 2s2, 2p5. Right? But the atomic number of protons are same: 12, 12, 12, 12 and 12. Now you compare three ionization energies. This is first ionization energy. This is first ionization energy. This is second ionization energy. This is third ionization energy. Sir, what is the first ionization energy? The amount of energy required to remove first electron from outermost shell is called as first ionization energy. What is second ionization energy? The amount of energy required to remove second electron from outermost shell is called second ionization energy. What is third ionization energy? The amount of energy required to remove third electron from outermost shell is called third ionization energy. Now you compare these three ionization energy. When you compare to these three ionization energy, the third ionization energy is greater than second ionization energy. Second ionization energy is greater than first ionization energy. The third ionization energy is always greater than second ionization energy. Second ionization energy is always greater than first ionization energy. Why the third ionization energy is greater than second and second ionization energy is greater than 1? Because after removal of electrons, after losing electron, what happens? Number of protons are same, but number of electrons are decreases. As number of electrons decreases and number of protons are increases, what happens there? The nuclear attraction, the force of attraction between nucleus and outermost electron increases. That's why size decreases. Size decreases. When size decreases, the removal of second electron is difficult. That's why we need more energy to remove second electron. Next, after removing second electron, the electronic configuration become a 1s2 and 2s2 2p6. In this case also, see here the number of protons are 12, but number of electrons are 10. Due to more number of protons, the remaining electrons are strongly attracted towards the nucleus. They are strongly attracted towards the nucleus. That's why we need more energy to remove third electrons. That's why the third ionization energy is greater than second. Second ionization energy is greater than first ionization energy. I will write here region. After removal of electron, after losing electron, what happens? Number of electrons decreases. Number of electron decreases, but number of protons are same. What happens here? If number of protons are same, if number of electrons are decreases, what happens? The nuclear attraction, the effective nuclear charge increases for remaining electrons. That's why the remaining electrons are strongly attracted to the nucleus. So more energy is required to remove the second electron. The number of electrons decreases, but number of protons are same. As a result, effective nuclear charge increases on remaining electrons. So the electrons are strongly attracted by the nucleus. That's why we need more energy to remove second electron and third electron compared to first electron. This is successive ionization energy. The next one, factors affecting ionization energy. The first one, atomic radius. Atomic radius is inversely proportional to ionization energy. As atomic radius increases, ionization energy decreases. As radius increases, ionization energy decreases. Now let us see one example. For example, this is a large atom, this is a small atom. In large atom there is a large distance between nucleus and electron. In small atom there is a small distance between nucleus and electron. In large atom, due to large distance, there is a less force of attraction between nucleus and electrons. So here we can easily remove outermost electron. We can easily remove outermost electron. But in case of small atom, there is a more force of attraction between nucleus and electron due to small distance. Here the removal of electron is difficult as compared to large size. Here to remove electron we need more energy, that is why it is difficult. It is difficult to remove electron. Here we need more energy, here we need less energy. That is why as the radius increases, less energy is required. That is why both are inversely proportional. Radius increases, ionization decreases. Why? As radius increases, the distance increases. As distance increases, the force of attraction between nucleus and electron increases. Sorry, the force of attraction between nucleus and electron decreases. Second one, effective nuclear charge. Effective nuclear charge. Effective nuclear charge. Effective nuclear charge is directly proportional to ionization energy. Effective nuclear charge is directly proportional to ionization energy. What is effective nuclear charge? The real attraction on outermost electron. If there is a more force of attraction between nucleus and electron, then more energy is required. That's why as attraction increases, as force of attraction increases, ionization energy increases. As effective nuclear charge increases, then ionization energy increases. Because if there is a more force of attraction, more energy is required. Next, the third one, screening effect. Screening effect or shielding effect. Shielding effect. Screening effect is inversely proportional to ionization energy. Screening effect is inversely proportional to ionization energy. As screening effect increases, then ionization energy decreases. Both are inversely proportional. What is screening effect? Total repulsive force, right? The total repulsive force is called screening effect. See here, this is nucleus, this is inner shell, this is outer shell. These are inner shell electrons, right? These inner shell electrons will work as screen around the nucleus. If there is a more inner shell electron, then there is a more repulsion between inner shell electron and outer shell electron. If there is a more repulsion, then what happens? The outermost electron will move away from nucleus. They will move away from nucleus. Then if there is a it moves away from nucleus, then the force of attraction between nucleus and the outermost electron decreases. In such cases we can easily remove outer electron. That's why less energy is required when there is a more repulsion between inner shell electrons and outer shell electrons. That's why screening effect means what? Total repulsive force. As total repulsive force increases, ionization energy decreases. Why? Because of more repulsive forces, the outermost electrons, they move away from nucleus. Then the distance increases. As distance increases, the force of attraction between nucleus and outer electron decreases. That's why we can easily remove the electron. Next, fourth one, stability of electronic configuration. Stability of electronic configuration. Electronic configuration. The stability of electronic configuration is directly proportional to ionization energy. The stability is directly proportional to ionization energy. As the stability increases, ionization energy increases, because in stable electronic configuration, the removal of electron is very difficult. So more energy is required to remove electron. For example, half filled means like P3, D5 and F7 configuration. Half filled means half number of electrons in orbitals. The maximum how many electrons we can fill in P subshell? 6. Half means 3. In D maximum we can fill 10. The half means 5. In F 14. Half 7. Half filled and full filled or completely filled and completely filled like P6, D10 and F14 electronic configurations are more stable. Electronic configurations are more stable. The removal of electron from stable electronic configuration is more difficult. That's why more ionization energy is required. See here P3 and P6 electronic configuration is more stable compared to P1, P2, P4 and P5. P3 and P6. See here. Between these electronic configuration, P3 and P6 electronic configurations are more stable. When you want to remove electrons from stable electronic configuration, you need more energy as compared to other electronic configurations like D5 and D10 also more stable compared to D1, D2, D3, D4, D6, D7, D8, D9. Similarly, F electrons also. F1, F2, F3, F4, F5, F6 are less stable as compared to F7. And F8, F9, F10, F11, F12, F13 electronic configurations are less stable compared to F14. To remove electrons from F14 and F7 is difficult. So more energy is required. Penetration power. Power of subshells. What is penetration power? Penetration power of subshell means the attraction of subshells by the nucleus is called penetration power. The order of penetration power of subshell. Penetration power of subshell is S is greater than P as greater than D and D as greater than F. S subshell has more penetration power as compared to P. P has more penetration power compared to D. D has more penetration power compared to F subshell. What is the meaning of penetration power? The attraction of subshells towards the nucleus. Compared to P, D, F, S subshell is more close to nucleus. Compared to D and F subshell, P subshell is more attracted by the nucleus, or it is more close to the nucleus. That's why in between S, P, D, F, the removal of electron from S orbital is more difficult. That's why more ionization energy is required for S subshell. These are the factors affecting ionization energy.